Welcome back to the channel, everyone. Today we're going to be producing messages from a Lambda to SQS and SNS. This video is coming from a viewer's request on one of my previous videos in the AWS Lambda series that I've been doing, which kind of covers how to use Lambda and interact with other services on Amazon. So in most of the other videos we've been doing, we've been acting as the consumer role. So typically in these distributed systems, or these asynchronous systems, you'll have producers which produce events, and then those events are consumed by some kind of consumer. So up till now, we've been having our Lambdas act as the consumer for events from SQS or SNS, or kind of acting as consumers of API gateways. So we can think of an API gateway almost as a producer, which produces incoming requests as events to Lambdas, which are then consumed and processed. But today we're on this right side over here. Today we're on this left side over here, and we're going to be acting as the producer ourselves. So we'll be building a Lambda, which will produce and emit events onto queues, SQS, and publish notifications to topics onto SNS. So let's get started. I'm just in an empty folder here in VS Code. I'm going to run go mod init pub lambda, and that'll just set us up with a empty module. That's good for now. Let's make main.go, and we'll open that up. So we're in package main here, and we're going to set up a couple of things here. So if you've watched my previous Lambda videos, you'll kind of know the pattern that we use here. We use this init function, which will set up global state. This will be run before our Lambda starts. Basically, whenever there's a cold boot or a cold start and our Lambda loads up for the first time, this init function is going to run first. So if we're going to be working with things like DBs, caches, loggers, anything like that, or other AWS services, right? So we need clients to interface those. That's what this init function is really, that's what it's for. It runs as the Lambda is booting up. And then below that, we'll have our handler. So this is just going to be some function that actually takes in the event that our Lambda received and processes it. And then finally, we'll have our main, and this is what gets called when our Lambda receives events. So inside of here, usually you'll see a lambda.start, and then you'll call your handler function. And we need to add this dependency. So let's do that now. We'll go get the package. And this start here uses a built-in context. So when you don't care about context being passed, what happens is it calls beneath the hood, it calls start with context. And it just uses this context.background, which is an empty context. There's nothing in there. So for us, what we want to do today, as we build out clients for other AWS services, for SQS and SNS, we want to inject those clients into a context and start our Lambda with that context. This way, in our handler, or whatever other functions we build out, we can use that context and some event, right? For now, I'll just leave that as an interface, but we can use that context and we can retrieve things from the context. So for example, get SQS client from context. So we would have a function like that, which would then give us SQS client. And that is how we could publish messages to SQS. So that's the general idea there. That's very high level. So to implement that, we just do start with context. And this function takes a context and a handler. So we need to set up a global state or global variable for that context. So let's do that up here. Context.context, and then inside of init, that's where we'll actually set our context up. We'll get it going. So context.background. And background is basically the empty context. So it's typically used in the main function or initialization and tests. That's the idea. So that's what we're doing here, empty context, and we're initializing things. And then below, we'll have some inject AWS client. Right, so this will inject all of our clients like SQS and SNS into our context. And then finally down here, is where we actually use that context. We inject it into our handler, and then our handler can make use of it. So other things that we want to put in, I want to put in a logger so that we can catch errors, things like that. So for that, I really like Uber's Zap logger, so let's go ahead and set that up. So zap.newProduction, and let's go get this package. Okay, so that's set up, and now I want to have a clean interface for this. So I want to be able to call something like logger inject context log. So I want to call just a function that takes care of, it takes in a parent context and it adds in our log to the context. So to do that, let's build that function. We'll make a folder called package. Within package, we'll make a folder called logger. And inside of logger, we'll make a logger.go. Package, logger, and then we're just going to say func inject. And this takes a context, and it takes a log, which is a zap.logger. And it's going to return a context.context. So now what we need to call, basically we're adding a value into this context. So we'll call context.withValue. And this is how you inject values into context. And it takes the parent context, a key to store it under, and then the actual value that you're injecting. So let's say ctx, we'll say logger, and we'll say the value. And this function returns a new context, so we can just return it. And if we do that, we'll get this warning here, should not use built-in type string as key for value, define your own type to avoid collisions. So what this means, if you haven't seen this before, in Go, when you inject values into context like this and you call with value, if another context is using the same key, like logger, you'd have a collision and you can overwrite the value that's actually stored in there. So to get around this, it's pretty straightforward. You make a custom type and a custom key of that type to use. So for us, we'd do logger key type and just make it be a string, and then just make a variable of that type. And the value could be whatever we'd like, but we'll say logger. All right, so now that gets rid of the warning, and we have this handy little inject function that we can put into over here, and we should be able to add the import now. So we're importing from our own package on logger package now, and that's just injecting this logger, this zap logger, into the context. So the next part that I want to work on is the actual AWS client. So how do we interact with AWS? How do we push, publish messages to SQS? And how do we publish messages to SNS? So let's get started on that. Let's go to package, and we'll create a new folder, and we'll just call it AWS. And I'm going to have two files in here. One of them is going to be called aws.go, and the other one is going to be context.go. So context.go is just going to be almost identical to what we have in logger. The reason I'm putting it in a context.go file rather than aws.go, is because aws.go is going to get pretty messy or a little bit larger. So I want to separate the two concerns, the two code bases. So context and what we use to inject our AWS client is just going to live in here. And then all of our code to actually build the client and push messages to SQS and SNS will live in this file, just so we have a little bit cleaner view into the code here. So let's change things around in here. I'll say AWS key type and AWS key. And we'll change these down, and this is going to take a client, and we'll call this just a connection. And this, yep, will return a connection. Sorry, it'll return a context. Okay, so this looks good. So this is our inject method for AWS. And now what is this type? So let's set up this type. And for now, I'm just going to make this an empty struct, just to get our context working. So now we can go back to main, and we can also inject our AWS client. And we do that by using the similar pattern, context equals aws.inject, ctx, and c. So now we need some new AWS connection. So let's close out context, we're done in there. And back in AWS, we'll make a new function, we'll call it new. And this function will return a pointer to a connection. So usually in a package that has its own struct or its own type like this, you'll see a new function that returns that, and this is a pretty common pattern in Go. If you have many different types of connection, or sorry, if you have many different types of structs, you typically see something like new connection, and then there would be a second function here called new connection 1. For us, just because we have a single struct, I'm going to keep with just new and assume that it's sort of intuited by the user that it's just a connection. And down at the end, we'll just return connection. Now back in main, we can set that connection up. So let's say C is aws.new. And now that gets rid of all of our warnings and errors in this main package. So we're pulling from our AWS package now and our logger. And we're setting up our global context, injecting everything into it. And then we are starting with context now. So one other thing with context before we move on, how do we pull things from it inside of our handler? So we need to add two more functions, two more helper functions. So in context, we'll start with AWS, and we'll say func get connection from context. And this will take in a context, and this will return a connection. So in here, we'll do context.value, and we'll use our key, and that's going to return the whatever value is stored within this key. And then we'll just need to cast this to the type, and we can return it directly. So one thing to note too, if this dot connection, if this cast fails, what we can do is also have C comma OK, and we can actually check if not OK. So whenever you do this type of casting in Go, you also get this OK Boolean, and in here you could do a panic, or additionally you could return an error from this function. For us, I'm going to keep it simple and just assume that we're always OK, and I'm going to return C. Okay, so here's get connection from context. Now let's get the logger from context as well. Get logger. This will return a zap.production. Sorry, zap.logger. And we'll cast that there. And we'll change the key. So that's it. Let's close out of these contexts. So now what we can do, for example, to get our logger, we can say logger.get from context and just pass the context. And then, just like we've done before in previous videos, you can call your regular, you can log just as before and just as expected. Similarly, we can do aws.get connection from context, and this will give us our connection object, which right now doesn't do anything and it doesn't have anything, but we'll add on to that and we'll add the functions we need. So let's go back to AWS now. We're pretty much done in logger. So there's a couple of functions that we'll be doing here. The first one is a function on connection, and it's going to be send SQS message. And for now, we'll keep that pretty simple. We'll add in the parameters and the response type later. The second one we'll do will be publish SNS message. And similarly, we'll keep that very simple. So now let's fill out this struct a little bit more. There's two things we can get from here. We can get our SQS client, which will be sqs.client. And we can also put in our SNS client. Just like that, and we need to add in these libraries. Pull the package. So that's done, and we're getting an unused. We'll use those shortly. So now, within these functions, send SQS and publish SNS, because we've set up these functions to have the receiver as a connection, so we have access to now these private variables within the struct. So within send SQS now, we can use those clients. So we can call c.sqs.send message. What does this take? This takes a context and a send message input, and then some optional function parameters. We won't use these optional ones, but we will need a context and we'll pass in our parameters too. So that means let's update our parameters for the function here, and we'll put in a context. Dot context, and also let's put in just a message, and we'll call it a string. Now then here we pass in our context and an address, sqs.send message input, and let's fill this just so we can see what we have available. So message body we have, QURL, that's something we'll need to get as well, but the rest of these are optional, and I'll leave it up to you to investigate and figure out whether or not you want them or need them. But the simplest way to send a message is just like this. So message body is a pointer to a string. So we can say address.message, and QURL, similarly pointer to a string, but we don't have that yet. So we'll hold off, and for now we'll just use what they have built in. And what does this return? This returns an output and an error. We don't care too much about the output. We can log it, but we do want to probably return this error. So let's change the response type here to be an error. And we want to log that output. So let's get our logger from context. Get logger from context, ctx. Now let's get our output and error. At the bottom, we'll just return error, and we're going to log our output. All right, so that looks good. We'll come back and we'll add in the QURL later on. But for now, let's do the same for publish SNS message. So inside here, we can access our SNS client and we can publish a message. And this looks pretty similar to sending SQS messages. It takes a context and the parameters, publish input here. So let's set those up. We need context, and we'll just say a message as well. CTX, and let's do address, SNS.publish input, and let's fill it to see what we can do. So the main ones we need is this message here, what we're actually publishing, and then also we need the topic ARN. So what topic are we publishing to? And if you don't know, if you don't understand the concept of a topic when it comes to SNS, watch my video on Lambdas with SNS, where we go a little bit more into depth into this. The rest of these are optional ones. Let's get rid of those. And this is a pointer, so we'll put pointer and address to our message, and topic ARN, just like Q, we'll come back to those. So this returns an output and an error. So it's going to be the same. We'll return the error, and we'll just log the output. So let's get our logger. And let's copy these lines. Published SNS message, we'll say that. And we'll say sent SQS message, just to kind of have these logs be a little bit different so we can tell the difference when we view logs later on. Okay, so there's our two functions now that we can actually call from our handler, and we will come back and revisit the QURL and the topic ARN, but for now that's good. So what's going to happen if we try to call these functions now? Well, if we've been using new, these clients aren't initialized, they're not set up yet. So that's our next step. We need to actually set up these clients here. Right, so we need to get some way to get an SQS client. To set up the clients, we need to load in our AWS credentials or AWS config. To do that, we use the config package. You can do config.load default config, and this function just takes a context. So we can do context.background. I'm going to use context.background because this is being used for initialization purposes, so it can just be an empty context here. Once you do that, this will give us a config, also an error, and probably you want to check if the error isn't nil and return it. So I'm going to go ahead and add another return parameter to this function. We'll put nil down here. Okay, and we need to import this package. So let's go get it. And now we get config is not being used. So here's where we set up our SQS client equals SQS dot new from config. And this takes in a AWS config and then optional functions, which we won't go into depth on. You can do things like specify your own HTTP client to do retries, timeouts, specify your own logger, that kind of stuff. We'll just use defaults for now. And this returns our SQS client. And we'll do the same for SNS, right here, SNS. And looking at this, we can just inline this like so. Okay. And let's see, any errors? Nope, cool. So we already have the SNS and SQS packages. All right, so now our connection's set up. We're gonna load our AWS credentials. If there's a problem, we don't have the access key, we don't have region set, etc., we'll get an error and we'll need to change this and we'll need to handle that in main. Otherwise, we return our connection with our actual clients. So now we have our real client set up, and now down here, this will actually work like we're trying to here. It'll actually send a message, and we won't get a kind of a nil pointer exception when we try to call a send message. Okay, so let's handle this in main. Now we have the potential for an error here, and if that error isn't nil, we don't want to continue on. We won't be able to do anything with the Lambda. So we want to log.fatal, and what will this say? Couldn't set up AWS clients. And let's log out the error as well. All right, so that'll stop execution right there. Okay, so that's taken care of. So the last stage, the last piece of code that I want to talk about is getting this config. And then as part of that, part of the configuration is going to be QURL and also the topic ARN. So this config looks for a couple of things. It looks for the region that we're in, the AWS region, like US East 1. It looks for your AWS access key ID, your secret access key ID, and optionally as well, it'll pick up the session token. So if you're working locally and somehow running this Lambda locally, you'll need to set those. But when we deploy this onto AWS, we get these for free. I'm here using AWS Lambda environment variables. And if we go down to defined runtime environment variables, we see that Lambda runtime sets several environment variables during initialization. These typically provide information about the function or runtime. So these are reserved and they can't be overwritten or set. And we see that we get AWS region, we get our access key, key ID, secret access key, and token in case we use that as well. So we don't actually have to worry about these. This line right here, just load default configuration, will work out of the box for us because of how Amazon has set up Lambda. What we do need to worry about is our QURL and additionally our topic ARN. So those are important things. We need a way to tell the Lambda what queue to send to, and we need a way to tell the Lambda what topic to send to as well. So these will actually be environment variables to do set and vars in Lambda. And I'm going to put this here as well. Okay, that portion's good. Let's go back to main, and now in our handler, let's actually call our clients here. So what we'll do is get our AWS client, get connection from context, and we need to pass in our context here. And then we can say AWS.send SQS message, CTX, and we will send that. And also additionally, we can do send SNS, publish SNS CTX, and hello SNS. Now you don't have to use a string here. If you wanted to send a JSON payload, some kind of struct along these lines, hello string, you would initialize that struct here, and then basically you would JSON marshal, and that you would take the byte output here, convert that to a string, and basically pass it through. So you would marshal your struct, which kind of stringifies this JSON here, and then you could pass that through to SQS and publish SNS, and then your consumers would be able to parse that JSON from the message. So that's kind of how you do that. And my other videos go into a little bit more depth on how to actually marshal and use that and unmarshal as well from the consumer side. But for us, we'll just use a very basic string. What does this return? This is an error. So let's do SQS and let's handle that error. We're just going to log it, log.error, couldn't send SQS, and we'll also add the error in. And similarly, we'll handle this, but we'll say SNS. And let's go ahead and log.info. And we'll say event. All right. So now our handler is pretty well set up. We got the logger from context. We're going to log out our whole event. We're getting our AWS connection that has our clients. And then we're going to send an SQS message and finally send, publish our SNS message. And we're just returning nil from this whole function here. So I'm leaving this as event interface because I don't care what kind of event this is that we get. This could be an API gateway event, this could be SQS, this could be SNS, any kind of event would work. For this purpose of this video, I'm not concerned about this. If you would like to set this up as kind of like a REST API, go back and watch my previous Lambda videos where we do that. We use API Gateway to create a REST API with Lambda. But yeah, so there we go. That looks good. And I think we have what we need here. So our last step is zipping this up and getting this actually deployed. So let me generate zip.sh, and we're going to say go operating system is Linux, and then go build main.go. And then we'll call zip function.zip main. Key thing to keep in mind here, we're doing go build main.go. Our handler is going to be called main. When you create Lambdas by default, that's called hello, so we'll need to change that. But besides that, yeah, that's it. So let's go ahead and zip this up. And we just need to give permissions here, plus x, generate zip. And let's run it again. All right, so that's done, and we have main, that's the binary that we generated here. That's going to be our handler eventually, but then we zipped it up into this function.zip file. Okay, so let's go ahead to the AWS console and let's upload this. So I have created this Lambda here called pub Lambda. It's just a blank empty Lambda. I used Go as my runtime, and like we talked about before, the handler by default is set to hello. So let's change that to main. And one other piece that we need to do as well is the configuration. So remember we talked about knowing what queue URL and then knowing what topic ARN that we need to publish to. So we need to set those here. So we'll need to add in a queue URL and we'll get that value. And then next we need to add in a topic ARN. So to do this, let me open up another tab here. And we're just going to go over to SQS. And we'll create a queue. I'm going to do standard. I'm going to run through this pretty quick. If you'd like to learn a little bit more about SQS or Lambdas with SQS, I have a video on that. You can check that out on my channel as well. But do standard. This is all fine. That's fine. We may need to change access policies in a bit, but we'll create the queue. All right, and we see here, here's the queue URL. So let's copy that. We'll paste that in. The next one is the topic ARN. This is what we need to publish SNS. So let's go to SNS. And I have a couple of topics that I've been working with. I'm going to use test topic here. And here's the ARN. This is what we need. And let's edit. And we will set this here. Okay, let's hit save. Okay, so now we have queue URL and topic ARN. These are two environment variables that we can use in code. So let's go back to VS Code. And we can actually use these. So, and here in our struct, we're going to add these. As fields. So we'll do queue URL, and it's going to be a string. And then we'll do topic ARN. It's going to be a string. And when we call new, we'll set these up. So we'll say queue URL is going to be os.getinv, and then queue URL. And if you want to make your code a little bit more robust, I would recommend checking to make sure these are set, and then possibly panicking or throwing an error if they're not. For us, we kind of are assuming they're set. Okay, so queue URL, topic ARN, that's good. And now what we can do is say c.queueurl, and it automatically sets the address for us because it needs to be a pointer. AWS SDKs really like pointers. Same thing here, c.topic ARN. Okay, so that's all taken care of. All right, so let's zip this again, and we'll go back to the console. We'll go over to code in pub lambda, and we're going to hit upload from zip file. And I'll select my zip, and we'll click save. So this will take a second, and we're all deployed. Awesome. Okay, so if everything works right, we should be able to go to test and invoke a new event. So let's go ahead and do this here. So my test event, yep, private's fine. And we don't need actually anything. Remember, we set our event as an interface inside of our code, so we don't care what's in here. We're just going to log it out from our Lambda. Okay, that's good. I'm going to hit test, and results succeeded. Let's go view the logs. And we've got our log stream here for today. And we see first the event. This is the event we received. We see a couple of other log lines that we got, but we do see errors. So the first one is permission denied. And what is the SNS error? Again, permission denied as well. So this is where access policy and roles come into play. We need to give the SNS publish action to this Lambda and the SQS publish action to this Lambda. So let's do that. We'll go into configuration. We'll hit permissions. And we'll go edit the role. So we're on the role here. I'm going to click add permissions and attach policies, and I'm going to look for SQS. And here we've got full access, read only, SQS queue execution. So these are pre-built ones. You can create a custom one if you want. I'm just going to use the full access for now. If you're doing production, don't do that. Do something a little bit more limited. Let's hit attach policies. That's good, and we'll do one more. SNS. And I'm going to do full access for SNS as well. And we'll hit attach policies. Okay, so let's go back to Lambda. Let's refresh. And we'll click test again. And we'll hit test. And we see succeeded, so let's check logs again. We'll click our log stream again. And now we see, here's our second request. So this is the first one we tested. We got errors. Here's the second one, and we see we received our event. And we published, we sent an SQS message, and here's the actual response. Here's the output. So that was successful. And we also published an SNS message, and here's the ID. So now we can go back, if we would like, to SQS first. And we'll click our queue and monitoring. This may take a bit to update, but it will update and we will be able to see the messages. But if you go to send and receive messages, you see one message available. Let's pull for it. And here's the message. And if you click it, here's hello SQS. So that's the message we sent there. I have this tab open for SNS. But for SNS, there's not a quick, easy way to view published messages. You need to create a subscription and subscribe and then log that out. So I'm not going to do that. I'm going to kind of just leave it to, hey, believe me, the message was published. Here's the message ID, and this is working. All right, so that's the video. This is the first time we've kind of gone in and showed how to work as a producer within Lambda. So we hooked up SQS and also SNS. We kind of showed the pattern of using Lambda with context and how you can use init on cold start to kind of inject all of the items you need, loggers, caches, DBs, other services, other clients, like you did with our AWS client. We were able to kind of build out this AWS package that acts as an interface on top of the SDK, the AWS SDK, and puts in helpful things like clients, SNS, and then different resource URLs that we need. But yeah, so that's the video. Hopefully this was insightful. Hopefully you're able to take away some things and build some new stuff on your own with this video. If you found this helpful at all, please make sure to like the video, comment, and then subscribe to the channel. It really helps out, lets me know I'm doing something right here. And feel free to recommend what you'd like to see next. It doesn't have to be with Lambda. It doesn't have to be with AWS. Anything around Go, I'm happy to cover and talk through. But with that being said, thank you for watching again, and I will see you all next time.